Hi guys, today we're going to continue our theme of enlargement, and it's just a brief thing to have a look at what happens to a 2 and 3D shape. Now if I started off with a rectangle that was 2 centimetres by 5 centimetres, and then I enlarge it by a scale factor of 2, I now get 4 centimetres and 10 centimetres. Now what I'm interested in is thinking about what happens to the perimeter for a start. So for the perimeter with this one, I would have 2 plus 5 plus 2 plus 5, so that would come to 14 centimetres. Now if I looked at this next one, the enlarged version, I would have 4 plus 10 plus 4 plus 10, which is equal to 28 centimetres. So it's easy to see that the perimeter has also been multiplied by the scale factor. Now if I was to look at the area, so 5 times 2 is 10 centimetres squared. In this one, 10 times 4, which is 40 centimetres squared. So that hasn't been times by the scale factor. So what has it been times by? Well, if I look at this and say that's 2 times 5, and this is 2 times the original 2, if I put that together or just change the order, I get 2 times 2 times 5 times 2. So you can see from that that this bit here is a times by 4. Now let's think about a bit more of a general case. So if I was to draw another rectangle here, that's a bit bigger than I wanted, let's do it like that. And I'd like you to imagine that this is not to scale. Well, you don't need to imagine it's not to scale, it's clearly not to scale. If I were to enlarge by a scale factor of 3, then if this is x and this is y, then this is 3x and this is 3y, because the x times 3 is 3x, y times 3 is 3y. You can see the area is xy, and the area in this one is 3x times 3y, which is 9xy. And it's no surprise then that has come from the 3 times 3, so it'll be 3 squared xy. And I think it's important to write it like that, 3 squared xy. The perimeter of this one is 2x plus 2y, and the perimeter of this one is 6x plus 6y. So overall, looking at it, the perimeter has been times the scale factor 3, but the area, which is different, is times by a scale factor 3 squared, and that's because you've enlarged one dimension and the other dimension. Okay, now if I was to enlarge a 3D shape, so let's see if I can draw a cube over here. And let's call that X, and that's enlarged to give me a bigger one. And let's call this one. Now let's go even more general. So let's say I multiply by a scale factor of f. So scale factor so the volume of this one would be x times x length times breadth times height, which is x cubed. And the volume of this one is fx times fx times fx, which comes to f cubed x cubed. So the volumes, by comparison, if I look at the volumes, it's times by a scale factor of f cubed, it's because we're working in 3 dimensions. So if you're working with length, so anything to do with length, if you enlarge, you use the same scale factor. If you use in area, because it's 2D, you enlarge by the scale factor squared, and when you're looking at 3D, which is volume, you enlarge by the scale factor cubed. So for example, if a 3D shape has a volume of 20 centimeters cubed and I enlarge it by a scale factor of 2, that would mean the volume would be enlarged by a scale factor of 2 cubed. 2 cubed is 8, so that 20 is times by 8, so the volume of the new shape would be 120 centimeters cubed. So just have a quick look at that. So the volume is 20 times scale factor of 2. The volume equals, and it would be 2 cubed times 20, which is 160. Okay, I think I've had to cover quite a lot there, so hopefully you've understood it. The idea is, if it's dealing with length, the scale factor stays the same. If you're dealing with area, because you're timesing 2 lengths together and both of those have been times, then it's the scale factor squared. And if you're dealing with volume, you've got 3 lengths times together and because each of those is times by the scale factor, the overall volume is times by the scale factor cubed, because it's times 3 times by that same scale factor. Okay?